Hi everyone, and welcome to this fourth episode of Git implementation. And today we are going to do blob hashing from the working directory. So we're going to hash a file basically. But before talking about that, I just wanted to recenter a bit the objectives of the chapter. So I kind of split the work in different chapters, and used to be I used to call that Git objects. But I think having maybe a bit clearer objective is going to help us to make sure that we are going towards this objective and not going around too much. And I think for this first chapter, the objective that we want is to be able to make a commit. But first, just a quick reminder. So if I take the last commit ID here, and I use the command, I put the command here that we use, so you can reference them whenever you need. Cat file -p with this hash. So this is going to show the commit. So we have the tree that corresponds to the kind of the snapshot of the directory of the working directory that was taken during the commit, the parent commit, the authors and committer, and the commit details here. And we can go further with that. So, for instance, if I try to show the tree, so we can see that here the tree corresponds to the root of the directory of the project, and it's consisting of blobs and trees. And if I, for instance, I'm gonna cat file this one so we can see the content of the file. So that's what I want to do in this chapter, and that's why we are starting by blobs, because you can see that blob is kind of the first leaf of the tree, and then we have the tree. So that's the next thing that we will do after once the blob is implemented correctly, and then we will do the commit. There are probably some subtleties that we're gonna discover as the project goes, but basically, yeah, the objective is to write this object and maybe provide the tree or the parent or the parent hash if we need. Okay, so now that I've hopefully clarified the objectives a bit, let's talk about what we're going to do today. So the first thing is going to be to change a bit the way we use the command. So during the first episode, you might remember that we implemented the command line to be able to hash some text that we provide as an argument. Loop. So with this command here, we are running the main and we are simulating hash content of this text here. But and this gives us the hash of this text here. But if we look at hash object here, if we look at the hash object command, what actually happens is that it's taking it as a std in the content to hash, and the default argument here would be the file, for instance. If I provide the readme, it's going to hash the readme. But if I wanted to hash test content here, I would need to echo it and hash it like that. For the sake of simplicity, I'm not going to do this with stdin exactly, but I've decided that I'm going to do just with text. So I'm just going to provide the argument test, and if we don't provide any argument, by default it's going to be a file. and then we are going to implement the hash of a file, hopefully if we have time during this episode. Okay, so first thing first, I have the main spec here. Let me open the main here. So first thing first, I want to print, I'm going to change the test here, print the hash of the string parameter test content. And so here is going to be a chunk, and there's going to be a first element, which is going to be ---- text, and we should have the same result. And so for the moment here, I'm just taking the head. I'm going to do pattern matching here to be able to catch this text. It's probably not the best option. I know that there are libraries that are useful for this kind of console defining console line programs. We are probably going to use them after, but for the sake of simplicity at the moment, I just want to do something simple enough. So what I can try to do is match. So when we have text followed by text and just that, we are going to call the command with text. Okay, and if we have any other thing, we do nothing for the moment. We can try to it's actually so git run the test main spec. Okay, the type is any, but if I put string here, oh, it's a chunk actually, yeah. So list. I thought it was a list. I didn't look close enough. And actually I don't need to provide a string anymore because by default is a list of string. Okay. I'm a bit surprised it's still compiling, but perfect. I'm just not going to handle this case for the moment. Potentially we can have an error eventually, but it's not the goal. We'll do that later on. Okay, so if we go back to our README, we transform that into that. So now I can actually try to run test content. So test content shouldn't work. Should throw an exception. Should throw in the. Oh. Okay, so the exceptions are not reported here apparently, which is bad. Let me try to use text. Okay, so that's correct. Create a new branch, episode 4, and we can commit everything. Now let's go to our main business logic. And let's do a bit of business logic at last. Okay, so I have here my use case and here my use case test. So we note that what's going to happen is when we're going to read the file, we're going to basically read a stream of bytes. And here you can see that we are also converting our string to a string of bytes. So what I like to do is convert this logic to accept a stream of byte by default instead of a string here. I like to also add one test first to test the encoding to make sure that the encoding is actually working. Okay. So it's not going to be test hash content, but I'm going to put some accents. I wanted to have, yeah, this. Okay, let's just try with this. Okay. And let's see if it works. Okay, so that's interesting. It's not working. Okay, so I figured out what was the problem here. The problem is that those characters here, they are potentially stored in more than one byte. And here we are using we are counting the number of characters and not the number of bytes. So what I'm going to do here is I'm going to put the string byte here. So instead of a string here, I'm going to take the bytes, and for the moment it's going to be the array of bytes, and we're just going to give the bytes here and create the bytes here. And it's not going to be str length, but bytes.length. And hopefully we should see this test passing. Well, actually it's not going to need to compile because we are missing the UTF-8 here. Yeah, of course, I'm putting the string here and the byte where actually, so I'm going to actually extract this in a variable. Can I extract that in a variable? Prefix. So it's gonna be our prefix, and then we can do prefix.get bytes. With the encoding, and then we can put, I suspect, the 0 byte here and bytes. Let's try to do that. So I think here this is to add to happen to the collection, and okay, the type here is char. Two bytes. Okay, I'm not sure. So the type should be better now. I suspect there is a associativity issue or something. Let's try like that. Nice. Let's add another test. let's try to hash an empty string. So if we hash the empty string, we should get this hash. Okay. So in TDD, we should first do the show the tests that fail, so red and then green, and then refactor. But here, I'm not doing that because it takes so much time to compile, so and to run. So I'm just going to not do that for this example at least. Okay. Finally, we are passing now. So here, what we have is that we are taking a byte array, but we can't do that with a file because a file might be big and might not fit in the memory. So what is done usually, as far as I know, is that there is a buffer that kind of reads the files part by part and then loads in the buffer, and then we can do some things on this buffer. So that's the first thing. The second thing is that when we interact with the file system, we need to close the resources that we are opening, close the files that we are opening. So all of this is a bit complicated to handle by yourself. So here I'm going to use Zio and especially ZStreams. ZStream is the stream implementation of Stream by Zio. And with ZStream, I can do from file, I think. From file name, okay. And I can provide the file name that I want. If we look at the implementation here, what we are going to do is, so there's this logic to acquire and release the resources. So here we are opening a file channel, and then we are making sure that it closes once we finish to use the stream. And what we are doing is that, as I was saying, we are allocating a buffer, byte buffer, and we're basically going to read the file, filling up the buffer, and refilling up as soon as we need more content from the file. So here I thought it was interesting to see the implementation of that. But what matters to us is more the type here. So it's going to return a ZStream of byte. So what I suggest is that with the examples that we have here, we transform these codes to have a ZStream of byte. And we are not going to implement the file now, but we are going to transform the string that we give as a parameter into a ZStream of byte here. I'm going to add the type. Okay, call that byte, and I'm going to call that byte stream. And byte stream is going to be from iterable, I think, iterable hash command. Hash object command. No. String to hash, get bytes, and I'm going to put the encoding here as a private var for the moment. always better to explicitly provide the encoding to avoid to have bad surprises in production. Okay, great. So now I have my byte stream, and what I can try to do is implement my SHA-1. So I'm going to start by doing a for that is going to yield the first thing that we can try to do is create our message address here. So you succeed. Create the message address. So we can use the first thing we need to have here is the number of bytes. So I'm gonna create number of bytes here. It's just gonna be byte stream dot run with can we count directly? I suspect not. I know that this works, so single count. Okay. So here I am going to read the file and count the number of bytes. And what I'm going to do next is I'm going to do kind of I'm going to read the file again, and for each byte we are going to digest update. Sorry, update, and at the end we can basically take this line here. Okay, so we are just forgetting to give we're forgetting to add the prefix here. Actually, I'm gonna use a function here. No, it's not a parameter, so it's a function. Provide prefix bytes. Okay, provide prefix bytes. I'm going to do get bytes and encoding. The length is definitely not that, it's int or long. And we don't need that here. Perfect. So now I can do my digest update with the prefix number of bytes. Okay, so here we should have something, the right results. Why is it found unit here? Okay, so the first thing here is that this takes an effect. So I'm going to take the byte here and does IO succeed? Succeed of bytes. Ah, is there an issue here? Okay, so there is a weird issue. Apparently we can't define variable like that anymore. Sounds weird. Okay, obviously the type is now wrong. I'm gonna put IO any. I'm gonna put a task actually. Task and the task because the task contained throwable by default and the task of string. The tests are not passing for some reason. Ah, okay, I think I forgot the 0 byte here. I'm gonna put 0 byte. Actually, I could put in the prefix. That would be better. And put it here. I'm gonna comment that out for the moment if I can find the right. Okay, so let's try to run that again. Okay, now we are providing the prefix twice. And the tests are still not passing. Oh, we don't need actually to byte anymore here. So let's see if that's a problem. Okay, perfect. We are finally running. So the next step is to have a file actually. So for the rest of the episodes, I'd like to focus on refactoring that first, because I'm not quite happy about that. How it looks very side effecty, if I can call it like that. So what would be nice here is to have kind of a sync. So we are going to have to go through the file twice or the string twice to be able to count and then to update the digest. But it'd be good to have this message digest a bit abstracted away from us. So what I'm thinking of doing here is creating a sync. So I'm going to create like a SHA-1 sync, which is going to be a for loop, a for comprehension, sorry. The first, so what we are doing here basically is a bit like a fold, like we are initializing the message digest at the beginning, which we can consider as the zero in the context of a monoid, and then we have the operation, which is update. The only difference is that at the end we have another operation that is required to give the information that we want. It's to call this function here and well to transform it into a string. into hash, into hexagonal. So what I'm thinking here is maybe we can use the for left of the sync. So at the moment, I think there is ZSync fold. Okay, so I'm not sure what would be the most efficient between for left and for left chunk. I feel like it would be for left chunk to update, to avoid to call this function update for each byte, but rather to call for each chunk of bytes. So here, if I give, so the 0 is going to be this message digest instance of SHA-1. That's going to be like the first parameter. And then we're going to have the digest and the bytes. And what we're going to do here is just digest update bytes. So let's say here the bytes are a chunk is a chunk and is expecting byte array. So is there a method to array? Okay, I'm going to suppose that there is. So this is going to give me back the digest here. The only thing I'm going to have to do is take the digest and call the digest on top of it. Perfect. Now, I don't need that anymore. So we have a bit of a problem here because we are going to need still to provide a blob. Let's see how we can do that later on. But for the moment, what we can do is just run SHA-1 sync. No, SHA-1 sync. And this is going to be the hash. Perfect. As we said, we still need to have the prefix. So what I'm going to do here is get the prefix for the bytes, like that, and concatenate with the rest of the stream, and run the SHA-1. Oh, we actually need to transform that into a ZStream as well. Dot from iterable. Now, let's see if we are passing, if the tests are passing. Okay, so here we can see that there is a bit of a problem. It sounds like a type issue. So usually specifying explicitly the type fixes the issue. Messiah's digest. Okay, I did the other way, obviously. Bytes. Oh yeah, and so here is not great. We have the Java API actually returns nothing unit, I mean. So I'm just going to return digest for the moment. I'm not super happy about that. This is a bit side effecty. Maybe we'll change that in the future. So let's see now if the test pass. Perfect, the test is passing. We can actually remove this function and this function here. So perfect. I'm quite happy about how the code looks. It's much better in terms of readability. This 4 is much better in terms of readability that we had before. So we are going first through the bytes to count them, and then we are first creating a prefix, concatenating with the rest of the bytes, and run through the SHA-1 string. And this is giving us back the hash. So I'm conscious there are some things that are missing in here, but compared to what we decided to do at the beginning. I'm going to finish that in the next episode. But in the meantime, thank you very much for watching this one, and I'll see you in the next one. Bye bye.